where I created the EC2 instances and the file system. It took a while because there were some issues. I don't know why. So what I did, I just deleted the EC2 instance and created it again, and then they worked. Okay. So if you want to do it again, you can watch the video and then know that. Okay. So now I'm going to bring the PowerPoint up. Okay. So I'm going to bring this today is databases. And by the way, we're almost done with the class. Okay, almost done. Guys, could anyone do the labs? No one? The lab 7?
No.
Okay, it's already open.
Oh, yeah.
It's open already. Okay. So guys, talking about databases today. Okay. So today we're going to see Relational Database Service, RDS. Very popular in AWS. Amazon Dynamodb, Amazon Redshift, Amazon Aurora, super highly available, high-end database. Amazon RDS console, Amazon DynamoDB console. I can do this, that's not a problem. And then Lab 5 is going to be about building a database server and interact with the database using an app. Okay. And there's a case study and the knowledge check. You're taking the knowledge check exam, right? The test, right? On Canvas. I hope you're doing that. Right? So after completing this module, you should be able to explain Amazon Relational Database Service, Amazon RDS, identify the functionality in Amazon RDS, explain Amazon DynamoDB, identify the functionality in Amazon DynamoDB, and explain Amazon Redshift, Amazon Aurora, and perform tasks in RDS database, such as launching, configuring, and interacting. Okay, so RDS is a managed service, right, that AWS has. Okay, so something that we have to understand before we study any service is that there are services that are not managed, and then there are services that are managed. Okay, if it is not managed, scaling, fault tolerance, and availability are managed by you. Okay, which is difficult and it takes time and a lot of work. Right? If it is managed, then it is done. It is built in the service. Okay. There are some services that have native high availability. Okay. But there are some services that are not. They don't have that built in. So you will have to work with them. Okay. We're gonna see some of the services that are managed. Okay. Okay, what are the challenges of relational databases? Server maintenance and energy footprint, software installation and patches, database backups and high availability, limits on the scalability, data security, OS installation and patches. This is exactly what you have to do if you have a database on premises. All of this, okay? All of this. You even have to do probably most of this or all of this if you have a database on an EC2 instance, okay? Which is almost the same as having your computer and installing SQL Server, for example, in your computer. All right? You have to install it, you will have to update it, you will have to probably troubleshoot it if there's a problem, right? Now, Amazon RDS is a managed service that sets up and operates a relational database in the cloud. Okay, guys, do you know what a relational database is? A relational database?
Yeah, sure.
Who's this?
Yes.
Who is talking? Do I have people here in the classroom?
That was me. Yes.
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 Okay, good. So Relational database, no, there's a relationship between tables, right? They have an referential integrity. They still keep the primary key and the foreign key, right? Every table has an ID that is unique, and that will be the primary key. And that primary key is going to be a foreign key in another table, and that's what relates the two tables. Like, for example, you have a table that is customer, and you have a table that is orders. So customer places orders, and an order has a customer that placed the order, right? So a customer can have several orders, but one order has only one customer. So that's going to be probably a one-to-many, like one-to-many, one customer, many orders. So you may have a customer ID as the primary key in the customer table, and then that same row may appear or will appear in the order table, but it's not going to be a primary key. It's going to be a foreign key. So that key in one table is going to show in the other table to establish the relationship between the two tables. So when you bring the information from the customer, you can also fetch the information from the order, and then you bring an entire object with the customer's information and the order. So that's what makes a database, that and other things is what makes a database relational. So we have a user here, and there's an application server, and then you're coming. Okay, so this could be like you may have an API in the middle, right? An API, and then API just will take the information from the database. In this case, it's AWS Cloud, Amazon RDS, right? Now, for on-premises databases to Amazon RDS. So we have on-premise database, application optimization, scaling, highly available database backups, database software patches, database software installs, operation system patches, operation system install, server maintenance, rack and stack servers, power, HVAC. So this, it's something that, guys, you have to work on. Okay. Now, you will have to work all this. Now, when you have an instance, an RDS on an EC2 instance, then you still have to do a lot of work, right? So you have to do all this except the last two, because that's something that AWS has in their data centers. The rack and stack, the physical servers are going to be there, but you will have to maintain the server. You will have to install the operating system. You have to patch it. You will have to update it. You will have to do so many things, the backups, everything, making highly available. But when you have an RDS, which is a managed service, the only thing that you have to do is optimize the application. The rest is done by AWS. So that's the good thing about having your services or your database with RDS or Aurora. When you have an Amazon EC2 instance, that's a server. And when you have a server, you have to maintain that server, right? Even though it is in the cloud, you have to maintain it because EC2 is not a managed service. It's an unmanaged service. RDS is. So that's the big difference between them. Okay? So managed service responsibilities. You manage the application optimization. AWS manages everything else. So just like here. Okay? You just manage this section here, optimize your application, make it better, make it more efficient, things like that, better code, better things, better SQL statements or SQL code language, and then this will be done by AWS. A lot of headaches that, guys, you're gonna.
It won't be architected. It's just available, right? Somebody has to know how to set up the high availability, the backup, and everything, right?
Yes.
So you do need the DBA for that type of reason.
Yes, but not
It
a
would,
regular one. Someone like a sysop administrator, someone like probably someone with this certification.
as a top,
Yeah, that's the.
so you would only leave the DBA for performance tuning.
You still may need a DBA, but to do things on the cloud, not working with physical servers. So because you still have to configure a database, someone that knows how to write queries, things like that. And RDS is not the only service that it is in the database section. You have other services, like for example, this one is very popular, Athena. Athena is a query data in S3. It's an interactive, cost-effective query service that makes it easy to analyze petabyte of data in S3 with no data warehouses or clusters to manage. So for this guy, you should have at least a basic knowledge of SQL. Okay, so the database administrator would not be working with physical servers. It's going to be working with the configuration of servers in the cloud, like database relational service engines. Still, I mean, you have all the services. You have Redshift, you have Aurora, you have Dynamodb. You have to create tables, right? You have to make those tables efficient, and then you have to have all the services integrated with those tables to fetch the information, right? But a guy that has a certification like this one, may be the trained person to work with a database, not only the database, also a systems and operations administrator. Okay.
It's kind of hard to see where the difference of um, responsibilities, where the line is drawn, because like, let's say you're a DBA and you learn AWS. What kind of certification would you jump into a SysOps certification, or would you want to stay in the database?
Yeah, there's a new one now that the person can jump to is database. Let me see. There's a new AWS database certification. Certification. Okay. Database specialty. There's a specialty right now. Is database. Let me see here. If AWS speaks something right here.
Is this
So,
new?
yeah, this is rather new. It was not here last year, but right now it is a new specialty. Okay, let me see if I can see the specialties here. Where's the specialties? I think it should be here. Okay, one moment. It should be here. Database, right here. It was not here before. Okay, this is a new one.
So you take the cloud and then you go to the specialty, or do you have to take the architect and then go to?
No, there's no prerequisites for any certification. You can go straight to this one. But the cloud practitioner is very helpful because at least you can have the basics of the cloud.
Yeah.
Okay? But before, for a person to take a professional certification, you had to have, it was a requirement to have at least one associate. Okay.
Gotcha.
Preferably the associate of the professional, because this one is a professional of these two, and this one is a professional of this one. Okay. Right now, you can jump from cloud practitioner to a solutions architect professional, which is not recommended at all, because you will be burning all these guys here, like not burning, like jumping all these guys here that are super super helpful to get clear these guys. These are tough guys. These two here, up here. I got this one, and believe me, when I was in the exam, I almost gave up in the middle of the exam because it's so much reading. It's a reading comprehension test. It's super long, super long. And sometimes when you're taking an exam and you don't care anymore, is when you pass. Has it happened to you guys?
No,
Oh,
I wish.
it has happened to me several times. Is it just that I don't care anymore because it's so hard and so difficult, and then all of a sudden, boom, I passed. So, and it was not. So it was like a fight between my willingness to finish the exam and my knowledge. It was, I know this, but I don't want to do it because it's too long. That fight, that inner fight in you, and you pass because you know. Otherwise, I mean, no one can pass this guessing. If you guess, you're not going to pass it for sure. So it's a hard exam. And this one, I have to take this one. I have all these 5 here, and I have to take this one. But this one is more reading than this one. That's what they say. It's more difficult than this one. But guys, once you finish this one and you take this ones, any of this one are gonna be easier, much easier, because you already have come through difficult ones. Those 3 here, they're not easy. They're not easy. The developer is the one that I found the easiest one. All right.
Professor, what is the job demand for these different certifications?
Oh, high.
Incredibly high.
Yeah, super high. And if you have a specialty, wow, that's even better. These 2, data analytics and machine learning, super high demand. Okay. And if you have an advanced networking or security, that's super good too. I know a person that I heard about the person that had he had a job as a networking guy, and then he passed this certification, which is a mean certification. It's not easy. This one is a hard one. And the person tripled his salary, like triple his salary when he got this certification. And he was immediately promoted with this certification. So any specialty is good, okay? But you have to see what field you're getting into, But if you're getting in the field of data analytics, super, super great. If you're doing for database, machine learning is super in high demand right now. Not many people know how to work with machine learning. It's super good. And there's many services. For example, one of them is SageMaker. This is for databases and machine learning. I'm sorry. Machine learning. Amazon SageMaker build, train, and deploy machine learning models at scale. One of the most popular services for that. When it comes to machine learning, you have to know this guy. Okay. When it comes to data analytics, you have to know this guy, Athena, and you have to know this guy too, Glue, Amazon Glue or AWS Glue. Okay. This is an ETL service that it extracts, transform, and loads the information. It will transform your data. Okay. Super good. It does workflows as well. Workflows. Okay. Super good. So let's continue. So we have this EC2 instance, not EC2 instance, RDS. And we have Amazon RDS, sorry. And then we have the DB instance class, CPU memory, network performance, DB instance storage, magnetic, general purpose, and provision IOPS. Okay, so you can type RDS here, right? RDS, and you can try to create a database, right? And then you can choose here, standard create. You can choose the engine. By the way, these are the 6 engines that RDS supports, right? Amazon Aurora by default is selected. MySQL, MariaDB, PostgreSQL, Oracle, and Microsoft SQL Server. So guys, don't forget these guys, okay? So all of them support SQL language, all of them. Okay, so we have here Amazon. I'm gonna choose. Let me choose Postgres. Okay. Let me choose my SQL Server. All right. So now I can choose the version I want, right? And then I can choose production, development, test, or free tier. I'm gonna choose free tier. But as soon as I choose free tier, then I won't have multi-AC deployment. What is multi-AC deployment? For failover. Okay. This is for failover. Just in case something happens, you can fail over to another availability zone, and then your database will be up and running again in no time. Okay. When you do this, you're going to create a standby instance. Okay. It will create a standby instance in another availability zone. But for that, I have to choose maybe production, and then that's going to be available. Okay. Where is it? I lost it. Right here. So it will create a standby in a different availability zone to provide data redundancy, eliminate IO freezes, and minimize latency spikes during system backups. All right. So there's going to be another database standing by, not doing anything, right? And at the same time is being synchronized synchronously. Okay, so every write that comes to the master database is going to be replicated. It's going to be copied in the standby synchronously. Okay, so that's going to be ready for when there is a disaster or something, and then you have to fail over, or there's maintenance on the master. You can move and promote the standby to master, and then it's going to be receiving all the reads and the writes. Okay. So for data redundancy and for high availability, we're going to have multi-AZ. Don't forget that. And for performance, to improve the performance of your database, you're going to have read replicas. Read replicas. Okay. The read replicas are asynchronously copied, right? All the information is asynchronously copied to the replica, right? And of course, it's a read replica. So it's going to be receiving reads only reads. The more reads you have, the better the performance is going to be. Okay. So you can promote a read replica to a master database as well, if you want to. Okay. So you can create here a free tier template, right? And choose the admin, the username, the password here. And also you can choose the storage type, provision types or magnetics. You can use auto scaling for storage, scaling out or in. You can use the default VPC, right? Remember that RDS is a VPC based service. You can choose a subnet group just in case you want to create a subnet group. You can make it public or private. Okay, if you make it private, then you will need a NAT, right? A NAT gateway or a NAT instance, remember? Because it will not be assigned a public IP. And then if you don't have a public IP, there's no way in this world that you can connect to that through the internet. Okay? But that database is going to need, upgrades. So the only way that you can connect to the internet to get updates is through a NAT instance or a NAT gateway. Okay? Or maybe a Bastion host. All right? I can select my availability zone, but maybe I don't have any preferences, so it's gonna put it in one for you. Okay. This is the port for my SQL Server, 3306. For Postgres, it's gonna be 54. Where is it? 5422. What's the port here? I think I have to here. Which one is this? Postgres. Postgres 3306, 3309. What is this? Okay, the default Postgres port 5432. I don't know what's giving me this port here, but that's the port. Okay? That's the port that PostgreSQL uses. Okay, so let's continue. These are the 6 engines, guys. Don't forget that. The 6 engines are here: MySQL, Aurora, Amazon Aurora, Microsoft SQL Server, PostgreSQL, MariaDB, Oracle DB engines. Oh, these are the engines. Amazon's in a virtual private cloud, so we have users using the Internet Gateway. They come to the public subnet. They have Amazon EC2 instance here in the public subnet, and then you have an Amazon RDS in the private subnet, right? So here, this is the multi-AC deployment. So you have a master here, and you have the, like I said, synchronously being replicated, right? And this is the standby one, okay? Now, multi-AC is synchronous. Replica is asynchronous. There may be some delay, some latency in the replication. All right. So we have here the public, and again the application here, and then the application is querying the database, right? Which is in a private subnet, and then whatever writes are being sent here, like you're writing in the database, is going to be replicated here, and this is going to be in standby, just in case something happens, right?
Is this only available for RDS, or is it available for the other engines?
Well, what do you mean the other engine?
The
Because
SQL Server has
that's
capability to do the same thing on the non-prem, and you're paying for that capability when you purchase a license.
right. This
Like,
is RDS.
yeah, so what I'm saying is this capability also in all the other engines.
Yes, is RDS. This is not a specific engine. This is RDS. When you have this, when you have RDS console, that's going to happen in every single engine. So whatever you choose, you're going to have multi-AZ here. You see?
This is
But
very interesting because, SQL Server has their own availability groups, high availability. Oracle has data guard. They all have some kind of package solution that is sold with their license. And AWS is saying, don't worry about it. We're taking care of it.
right, this is managed. Okay, now these guys are like a content in a container. The container is RDS, and then inside you have the engine. The engine is going to be covered by that availability, no matter what engine you choose. All of this. RDS is the one that has multi-AZ. This is a feature for every single engine because it's RDS. No matter what you choose Oracle.
I see.
Oracle, you're still going to have multi-AZ. Right? It's RDS, it's the service, not the engine. Right?
Yeah.
Good. So if this guy is down or is under maintenance, for example, this guy, you see the application will not search, will not do this, and it will do this. Okay, come to this one. Okay. So read replicas, that's what we talked about before. Don't forget that this is for high availability, and this one is for performance. Okay, performance. Let's see that your database is under heavy traffic and a lot of requests, and you know, reads. What do you have to do? Create a read replica, and then the traffic is going to be routed to both databases, not only one, right? To the Amazon RDS master data instance and to the read replica instance, and then you offload the burden of the master database. Okay. So it offers asynchronous replication, like I said, multi-AC is synchronous, read replica is asynchronous. It can be promoted to a master if you need. Used for read-heavy database workloads and offload read queries. You know, this is only for reads. You don't receive writes in this one. That's why it's called read replica. It's not a write replica. Okay. You can promote it to a master if you want to, but in the meantime, there's only one master, and you have, you know, read replicas to improve the performance of your database. Web and mobile applications. You can use this for high throughput, massive storage scalability, high availability. In the case of e-commerce applications, low cost databases, because it's not expensive. Okay, it all depends on the engine. If you're using Aurora, well, you have to pay some money. Okay, because you're gonna see why. All right. Also for data security, it's very secure, and for fully managed solutions. Okay. Mobile and online games rapidly grow capacity, automatic scalability, and database monitoring. Because this also has monitoring. CloudWatch is also, you know, monitoring this guy. Okay. When to use Amazon RDS, when not to use it. Now, if you have complex or transactions or complex queries, this is a good moment to use RDS. All right. Don't forget that Dynamodb has queries too, but they're different. They're not SQL. Okay. Dynamodb is a NoSQL database. RDS is a SQL database. Okay, guys, we're gonna be talking until 7, and then we get our break. Okay. It's 6:52 now. So a medium to high query or write rate up to 30,000 IOPS, 15,000 reads, and 15,000 writes. So that's when we use RDS. So you have to see what your business needs, and then based on that, you go for the database that is most suitable for you guys. Right? No more than a single worker node or shard. When you have shards, that you have to use something else. You can use Kinesis. Kinesis is for real-time data ingestion. It's a real-time data ingestion service. Okay, or maybe a Dynamodb, which is a single digit millisecond performance database. Super fast, right? It can even be global. Dynamodb can be global because you have global tables, right? And high durability. Okay, so these guys are the thermometer that you can use to know if RDS is the way to go for your business, right? Now, if it is not this, then don't use RDS. You have to use something more powerful than that, right? So if you have massive write rates, for example, 150,000 write per second, then RDS is not the guy for that, okay? Because this guy is for 50,000 reads and 50,000 writes. You have 150,000 writes per second. That's super fast. Sharding due to high data size or throughput demands. When it says no shard, when you don't need shards, then this is the guy. If you see shard, you need shard. It's like partitions, right? If you need to partition your database, something like that, then you have to use something faster than that. Simple get or put requests and queries that a NoSQL database can handle, right? If a NoSQL database can handle, then this guy is not for you because this is a SQL database. Also, Relational Database Management System, RDBMS customization. If you need to customize your database, this guy is not for you because this guy is managed, so you don't have control on the customization of the database. Okay. So clock hour billing and database characteristics. This is about billing. The resources incur charges when running. If you're not running, your database is not incurring any charges. But if you are running it, yes. Now, database depends on what? Depends on the engine size and memory class. Okay. So this is what's going to determine how much you're going to pay for that. If you choose, for example, here production, let's see the price. Look at this. That's going to be per month, guys. This is not per year or something. This is per month. Okay. But we're choosing a production database in Oracle, right? And then we're using a DB database, right? This is the instance class, a database.m5.x large, which has 4 virtual CPUs, 16 gigabytes of RAM, and an elastic block store, 4,750 megabits per second.
That's not large.
Huh?
That's an average small.
Yeah. But you know, it's I'm sure that compared with the on-premises, this is going to be less money. I don't have the data from premises, but
Depends, like a physical server, physical node between, I don't know, $35,000 and $75,000 for the physical server. And then you have to buy the license, which is what's more expensive. And AWS is not giving you the license.
yeah,
You will bring in the Oracle license, which in AWS is more expensive than if you put it in Oracle.
you have to buy the license if you use an EC2 instance, and then you mount that.
Ah, okay. So here you don't have to buy the license?
No. This is managed.
Oh, that's nice.
That's what makes it cheaper. This is managed.
Yeah, of course.
This is managed by AWS. You don't have to worry about anything.
Oh, wow. So do me a favor, go to the standard and see what the difference in price is.
This, what is it? The standard what?
Standard edition, up in the middle, right? Right there in the middle. How much did it go down?
Same price.
Same price? Why would you even go standard then? Let me see, efficient, reliable, smooth management.
But your own license here. License included.
This is included for standard only. Wait.
Yeah.
So license included is 1,000. Bring your own license is 600.
So standard, the license already there, and it's cheaper.
Mm-hmm.
And Enterprise Edition, it has other versions, right?
But it's only bring your own license.
Bring your own license here. Yeah, this is for your own license.
So only the standard edition one is the capable of being managed.
Mm-hmm.
Okay.
Yeah, it's
1,300.
this you have choices, but if you do this on an EC2 instance, you have no choice. You have to bring your own license.
Yeah. Okay.
And you're gonna work more for sure. All right, so we have ours here more about this purchase type and multiple DB instances. So this also influences your the cost of that. If it is on-demand instances, compute capacity by the hour. If it is reserved instance, you can also reserve for 1 year or 3 year term. Upfront payment for databases that are reserved with 1 year or through low one-time upfront payment. So this also has some similar billing model as the EC2 instances. The number of DBs, of course, how many instances are you preserving, are you purchasing, are you paying for, that will influence the price, of course. Okay. Also, for example, there's no charge for backup storage of up to 100% of database storage for an active database. So in other words, backup is free. Okay. Okay. Almost free because it says up to. All right. So the charge is gigabytes per month, backup storage for terminated DB instances. So if you terminate a DB instance, right, and you still have some backup there, you're gonna pay for that. So you see, if it is active, you don't pay for it. If it is terminated, you pay for it. Okay? So in other words, you better keep running. You better keep it running, right? Pretty smart. Also, additional storage charge gigabyte per month, and backup storage in addition to provision storage. Okay.
But we talked about Glacier as being the cheapest storage for backups.
Yeah, but this is different.
So this is a different layer.
These guys, they have their own section for backups.
Hmm.
If you want to delete the database, you have snapshots here, where you
Mhm.
set them here. Okay. You can have automated backups and put them here. You don't need to put them in an S3 bucket. You can keep them here,
Hmm.
right?
Could you take them out of here and put it in an S3 bucket
Um,
if it's cheaper?
let me one moment. Let me see this.
This is just an export from Oracle, and it's a 2 gig export.
You can export a DB snapshot to Amazon S3 using the AWS console, the AWS CLI, and the RDP. Yes, I thought I don't see a reason why, but I was not sure
Uh-huh.
why you wouldn't do that, because S3 bucket is the best place for snapshots and RDA instances. I think it's a good move if you are deleting this guy, and also
Mhm.
money as well, to send money, because this guy is I mean, S3 bucket is super cheap
Mhm.
when you store things, and like you said, if you put them in Glacier and you archive them,
Mhm.
use them whenever you need them, then it's going to be much cheaper than that.
Yeah, sometimes you have to back up and keep it for like 7 years. You're not gonna be paying for 7 years of that much data.
Also, the requests, the queries, the number of input and output requests that are made to the database, that's going to influence the price. Deployment type, if it is a single availability zone or multiple, if it has multi-AC or only one AC, the more highly available you are, the more you will pay. Okay. And also, data transfer, no charge for inbound data transfer, and tier charges for outbound data transfer. We know this already. The same principle applies to the entire AWS. Okay. So guys, it's 7 o'clock, right? Well, 7:03. Let's have a break, a 10 minutes break, and let's meet back here at 7:13. Right? Well, guys, back here. So the task for Lab 5 is designed to show you how to use an AWS managed database instance to solve a need for relational database. Okay, so you have here an AWS cloud. The AWS cloud, you have the internet gateway, VPC with CIDR 10.0.0.0/16. You have two availability zones. This VPC spans two availability zones. You have public subnet 1 with CIDR 10.0.0.0/24. And you have another public subnet 2, 10.0.2.0/24. You have a NAT gateway in the public subnet for the availability zone A, and you have a web server with a security group in availability zone B. So then you have two private subnets, one with subnet 1 and then one with subnet 3. So when I say 1 and 3, I talk about this byte here in the IP address. Okay, 0, 1, 2, and 3. Okay. So what are we going to do in the lab? You're going to create a VPC. Sorry about that. A VPC security group, create a DB subnet group, and create an Amazon RDS DB instance and interact with your database. So this is going to be the final product. Okay, you're going to have exactly the diagram that you had before, but now you're going to have a database here in the private subnet 1, and then you're going to have another database here, a secondary one, which is a standby one with a security group as well. All right. So that's the final product of the lab.
And that it's not published when you go to view.
No, it's not published yet. So the RDS demo, that's something, guys, that you can watch later. How do you do it? I gave you just a little overview of how you would do that. Okay. I can do this here, create a database. I'm gonna create a standard is, let me choose a sequence, MySQL server. I'm gonna use this engine and use free tier. Right? A database instance identifier. I'm gonna call it MySQL database or MySQL DB. Okay. The admin is gonna be the master username, right? I'm gonna use a password. I'm gonna use the word pass, right? Just to make it simple. I'm gonna confirm the password. DB instance, I'm gonna use T2 micro, which is included in the free tier. General purpose, allocate storage 20, that's fine for now. 1,000 maximum storage threshold. Okay, enable auto scaling. I cannot do multi-AC, that's not included in the free tier account. The default VPC I'm gonna use is the one that I have by default. I cannot change the VPC selection after I have created a database. I will have to recreate the database if I want to change the VPC. Okay, I'm gonna select, I'm gonna make it initial database name. I'm gonna select I'm gonna select here, say my database. My database. Okay. The retention period is gonna be 7 days. Okay. It's up to 35 days. Okay. Backend window, there's no preference here. If I select here, I can choose the start time, and then I can put every min 2, that's the duration. I can copy the tags to Snapshot. I can select enhanced monitoring every 60 seconds is the highest. Okay, that's gonna cost money, guys. I can use a monitor row. I can do some log exports, error log, general log, slow query logs. I can select for maintenance window, select the window here, and just do a maintenance window every, I don't know, every day if I want to do that. No preference. I can have a deletion protection, for nobody will be able to delete it unless this is unchecked, right? And then I can create a database. But I have a problem here. The database is not right. Okay.
Can you see the cost?
No, it's free. It's included in the free tier.
Oh. Oh, we did select.
This is the free tiers choices. There's no cost. All right. Of course, you have 750 hours for free. After that, you're gonna be charged. All right. Those are the limits. It's exactly like EC2 instances. You have 750 hours a month. So it's gonna be creating the database there. We're gonna be able to see it later. It takes a while. Okay. So with Amazon RDS, you can set up, operate, and scale relational databases in the cloud. Features managed service, accessible via the console, AWS command line interface, and application programming interface API calls. Scalable compute and storage, automated redundancy and backups are available. Supporting database engines, Amazon Aurora, PostgreSQL, MySQL, MariaDB, Oracle, Microsoft SQL Server. Okay. Guys, what are the engines that RDS supports?
MySQL, SQL Server,
MySQL,
SQL Server, Oracle.
Oracle, MySQL, Postgres, MariaDB, Aurora.
okay.
Okay.
Aurora, PostgreSQL, MySQL, MariaDB, Oracle, and Microsoft SQL Server. Okay, this may be a question in your exam. Okay, so it's still creating. It takes a while to be created. Okay, so Amazon DynamoDB is a very tough guy, right? So it's a no relational database, no SQL database, right? You don't use SQL for this guy. Okay, so SQL will have a regular table has rows and columns. It has a schema that is fixed, right? And is using SQL, is vertical, so it goes up, right? And you can have, this is that example right here. Now, in the case of the non-relational database, in this case, DynamoDB is a key value pair document, right? And graph. It has a dynamic schema, so it's very crazy when you see it, but it's super powerful. It focuses on collection of documents, horizontal, so you can reproduce the table several times. Horizontal, it means the amount of tables increments, and this is the amount of power that's vertical. And as you can see, it's a JSON document, right? That has value pair, key value pair rows here, as you can see. I'm gonna show you the table. Fast and flexible NoSQL database service for any scale. Any scale, okay? There's some instances that the DynamoDB is not the way to go, like we saw in when to use RDS. You're gonna end up paying more with DynamoDB when you can use RDS if it is small scale. It's virtually unlimited storage. There's no limit for this guy. There's no limit for this guy. Items can have differing attributes. So remember, in a relational database, you will see that every single row has an ISBN, a title, author, and format. With this guy, you may have one row that has ISBN and title, another row has ISBN, title, and author, another row has author format. It's not a fixed schema, it's dynamic. Okay. Still super powerful, more powerful than RDS, and it's very special for games. Very highly used in the gaming industry. Okay. Low latency queries is super fast, scalable read write throughput. You can increment the write capacity and the read capacity easily, right? You have tables, items, and attributes are the core Dynamodb components. Okay, tables, items, and attributes, right? It doesn't have rows and columns. It has tables, items, and attributes. Don't forget those words when you mention it. When they mention a table that uses tables or items and attributes, that's Dynamodb. It supports two different kinds of primary key. You have partition key and partition and sort key. Okay, so you can have partition key only or partition and sort key. Okay, that's possible too. Usually the sort key is a key that can be sorted, like a date, maybe a date of birth, a date for an event, things like that can be sorted by date, something like that. Partitioning, as data grows, table partition by key. Query by key to find items efficiently, scan to find items by any attribute. So you can use query or you can use scan. With query, you can use the key to find the items efficiently. For scan, you find the items by any attribute. Okay? Now, items in the table must have a key. The key has to be there. It could be a single key or a compound key, also known as composite key, a composite key. Okay? So you have a partition key, that's a single key, and then you have the attributes. Or you can have the partition key and the sort key, which is a compound key, right? And then you have the attributes, right? Similar to a table in relational database, you can have, a compound key. You have two primary keys, right? And then you can find items easily that way. Or you can have a single primary key in a relational database. So that was fast, right? That was quick. So Amazon DynamoDB, it runs exclusively on SSD, okay? Exclusively on SSD. It supports document and key value store models, replication tables automatically across your choice of AWS regions. It works well for mobile, web, gaming, ad tech, and Internet of Things, IoT applications. It's accessible via the console, the AWS CLI, and API calls. Provides consistent single-digit millisecond latency at any scale. So from 1 to 9 milliseconds latency. So it's super fast, right? And has no limits on table size or throughput. Guys, this table is amazing, okay? Of course, it's gonna be, it's not gonna be cheap, but remember, you only pay for what you use. Don't forget that, okay? So I can come here. As you can see, it's available right now, right? It's available right now. I didn't choose yes. So this table, this is not gonna be accessible because it's not yes. So if I want to use, for example, do you guys know this guy? D Weber? Have you ever used this guy?
No.
It's a universal database tool. Okay, I can connect this to my RDS, and then I can work from DB Weaver and create the tables there and create everything there. Okay, so let's see that as the hosting the hosting database and the database itself, which is when you create the queries and you create the things, right? And then you can connect this to an application and then get the information from here, from the database. When you create a DBeaver database, I think I have it here. Let's see here. Okay.
This is for DynamoDB?
This is for RDS.
Oh.
DynamoDB has its own platform.
Okay.
But I have this guy here that I can use. Let's see if I can. One moment. I have this guy here. Postgres. And then I can just connect. It's not connected now. But then with this guy, I can connect the database, right? You see? Postgres, MariaDB, MySQL, Oracle, SQS, Apache, Phoenix, all these guys. I choose this, and then when it asks me for the host, I can use the host here. If I take a look at this is the endpoint.
They're free?
I'm sorry?
It's free?
What? Sorry?
DB, is it free?
Oh, yes, this is free. Yeah. This edition.
No. The client tool to connect.
This edition is free. Yes, this is free. So you can put the endpoint here, the endpoint, and then you can put this guy, and then let me see if it connects. The username, I remember the username was
Admin.
Admin, right?
Mm-hmm.
Let me see. Configuration. Okay, I think it was my SQLDB. My SQLDB. Let me see. And then it was password.
You connect to to MySQL with the Postgres?
Oh, that is true. It would not connect. Yeah, I'm more used to using Postgres than anything else. Okay, so it was MySQL, right? Forget about it. So you see, it cannot connect. So this is the guy. No, this is not the guy. It was SQL Server, right? The one that
MySQL.
MySQL?
Yeah.
Okay.
The master username is admin.
MySQL. Yes. This one, right? So I'm gonna use the
Go down. Oh, go back. Go back to configuration.
So as the host,
Yeah.
database is this
My SQLDB. Yeah.
Database is this one, and then the username is this one.
No, it's admin. Go to the right. Master username.
It's all the way around. And then MySQL is my.
Okay.
Right?
No, it's admin. Master username is admin.
Oh, it's fine there. Yeah. And then password. Yeah. I will have to download this guy.
Mm-hmm.
And then
So when do you pay for this? What is it the paid version give you?
I've never charged the paid version.
Oh.
This is free. But I always use it with Postgres. I have never connected to this guy. I have to make some time for this guy. I thought I had chosen Postgres.
Did we open the port on the security group?
It's open. It's open. But I have to give more thoughts to this because I never connect to this. I always choose
Can we look at the logs really quick?
maybe another time. I don't have much time for this. So connection timeout.
It doesn't even make a connection.
The last packet sent successfully to the server was the connection timeout. All right. Yeah, you can try this in your house. You can download DVViewer and connect to. I always connect to Postgres. For some reason, I like Postgres better. Okay, let's continue. So we have this guy here, and then we have Dynamodb, and then Dynamodb is here. If you come to Dynamodb, and then you can create tables here. Create a table, for example. I can give it a name, my table, my DynamoDB table. Partition key, it can be a string, and just give it provided ID. And then just the all for now. So it's gonna create a table for me. As easy as that. So the table is already created. Let me create some items here. So I create an item. I can say ID. Let me say 001. And let me add another guy. Let's say first name. And then Dunieski. All right. Maybe I'll paint another one. Let me say last name. And let me say Otano. And let me say probably phone number. And let me say 0, 1, 2, 3, 3, 4, 5, 6, 7, 8, 9. Right? So that will be one object here. Okay. So I can create another one. And now I can say ID 0002. And then I can say H. I can say 30. And I can say here address. And I can say 4 Southwest, maybe say Avenue, Miami, Florida, 3344, this. And then I can say save. You see how schemaless it is? Schemaless it is. So this one has different attributes, okay? And this one has different attributes. Still, I can query a database, right? Maybe ID if it is 001. And then I can search and I find this guy. Okay. Or I can do 002 and I find this guy using this query operation here. Or scan if I want to scan the entire thing. Maybe first name. Then equals Dunieski. Then it found this. All right. So you can have a Lambda function that fetches information from this. I have some code for a Lambda function that brings whatever we have in the database in the DynamoDB, but I don't have time for that now, guys. So I can do that in another moment. Okay, Redshift, it's a data warehouse, right? So the keyword is data warehouse. You can use that with complex SQL query. By the way, it supports SQL, right? And then you can bring the information from the warehouse using SQL. Okay. So it does parallel processing, so it can do different operations at the same time. Okay. You can have an SQL client or a business intelligence tool And then you have some little nodes and dense compute nodes. So nodes there. You can have an Amazon DynamoDB and Amazon S3 there too. So the little node, what it does, it manages communications with client programs and now communication with compute nodes. It parses and develops execution plans to carry out database operations. Specifically, sorry about that. Specifically, the series of steps that are needed to obtain results for complex queries. So the little node compiles code for individual elements of the execution plan and assigns the code to individual compute nodes. The compute nodes execute the compiled code and set intermediate results back to the little node for final aggregation. Like other AWS services, you only pay for what you use. You can get started for as little as 25 cents per hour, and at scale, Amazon Redshift can deliver storage and processing for approximately $1,000 per terabyte per year, with 3-year partial upfront reserved instance pricing. See, Amazon Redshift Spectrum feature enables you to run queries against exabytes of data directly in Amazon S3. As you can see, Amazon S3 is everywhere, even in conjunction with Redshift. Okay. So this is the dashboard. I don't have anything here, but you can create a cluster, right? And in that cluster, you can choose a node type, right? This is the one that AWS recommends. Configuration summary, $4,685 per month. Right? So that's the estimated on-demand compute price. But if you reserve nodes, right? If you reserve nodes, then you're gonna save up to 60% of that. It says it here, save more than 60% of your cost by purchasing reserved nodes. All right. So it's like any other service in AWS. The more you buy, the more you save. Okay. Here you can go for the free trial. The free trial still has estimated demand compute price $2,190 per year, which is 25 cents per node per hour, like I just told you guys. Okay. So this is the port number that it uses, 5439. Okay. And you can have this integrated with S3 and DynamoDB. Okay. If your organization has never created Amazon Redshift cluster, you're eligible for a free limited time trial of our DC2.large node. The following are estimated charges if you're not eligible for a free trial. You can learn more here. Now, if you estimate it for 1 year, look at the price. 1,400, 2,190 if there's no reserved. But if you reserve 3 years, look at how much you're saving. It's $879 per year, right? Okay, so you're gonna pay probably $2,500 more or less for 3 years, more or less. So here you're paying $2,100, almost $2,200, $2,100 per year. Here you're gonna pay around $2,500 per 3 years. So you're saving a lot of money. Right? So in a period of 3 years, you're gonna be paying here $6,000, a little bit more. So you're saving here like probably $2,500. That's a lot of money. Okay. So it's a good choice to go with 3 year and reserve money. Automation at scale, you can have manage, monitor scaling with Amazon Redshift. Right? It's compatible with SQL clients and business intelligence tools. Okay, just in case the company has that, It's compatible with that. So it's compatible with the things that you already know, guys, and you use. It supports standard SQL. It also provides high performance Java database connectivity, JDBC, and open database connectivity, all DBC connectors, which enable you to use the SQL client and BI tools of your choice. Okay. Now, this slide discusses some Amazon Redshift use cases, right? So many customers migrate their traditional enterprise database and data warehouses to Amazon Redshift with the primary goal of agility. So they want to make their warehouse faster. Right? Customer can start at whatever scale they want and experiment with the data without needing to rely on complicated processes with their IT departments to procure and prepare their software. So big data customers have one thing in common: massive amounts of data that stretch their existing systems to a breaking point. So smaller customers might not have the resources to procure the hardware and expertise that is needed to run these systems. With Amazon Redshift, smaller customers can quickly set up and use a data warehouse at a comparatively low price point. This is a managed service, right? And as a managed service, Amazon Redshift handles many of the deployment and ongoing maintenance tasks that often require a database administrator. So this enables customers to focus on querying and analyzing their data. So this may not need or may not require a database administrator. Okay? So you instead can focus on customer and analyzing your data and query your data, right? So also, software service customers, the people that use software service, they can take advantage of the scalable, easy to manage features that Amazon Redshift provides. So some customers use Amazon Redshift to provide analytic capabilities to their applications. So some users deploy a cluster per customer and use tagging to simplify and manage their service level agreements, SLAs, and billing. Right? Amazon Redshift can help you reduce hardware and software costs. Okay, great solution for companies that they have data warehouse, and they want to migrate to the cloud. So Amazon Redshift features, among them, we have that is fast, fully managed. It's not managed only, it's fully managed data warehouse, right? It means that, guys, you don't have to do absolutely nothing, okay? With the underlying infrastructure. It's easily scalable with no downtime. It's a columnar storage and parallel processing architecture. Automatically and continuously monitors clusters, and encryption is by default. Okay, so you don't have to do anything with encryption. You don't have to print anything. It's already encrypted. Okay. Now let's talk about Aurora. Guys, do you have any questions?
No.
It seems that sometimes I'm alone in the classroom. Are you guys here?
Yep.
Guys, I was just informed that everybody in the class got access to quiz labs, which I talked about at the beginning of class. Okay, so please, when you have some time, check your email. Make sure that you check your junk email, okay, junk mail, because that should be there. Okay. And start using it as soon as you can, guys. As soon as you can, right? Because you only have a few days before the exam. So try to use it. Go to the section where it says practice exams and use it there. Okay. So this is an enterprise class. Relational database is heavy duty. It's for enterprises, right? It's compatible with MySQL and PostgreSQL. So it uses SQL as a language, automate time-consuming tasks such as provisioning, patching, backup, recovery, failure detection, and repair. So it's self-healing. It will take a lot of burden off you guys. Okay. It's a little pricey, but you're gonna save a lot of time. So it's a managed service. It's fast and available, right? It is simple, compatible, and pay as you go. Like any other service in AWS, you pay as you go. So it means that you only pay for the services and features that you use. It is a managed service that integrates with features such as AWS Database Migration Service, also known as DMS, right? And the AWS Schema Conversion Tool, and which is very useful when you are migrating to the cloud. Let's say that you have Oracle, right? Oracle, and then you want to just take it to the cloud, right? AWS has a database conversion tool that will convert that into the cloud format, right? Still the same engine, but it's in the cloud.
How about store procedures and triggers and stuff like that, functions and stuff? Does it translate all of that?
Oh, it does. This same guy here that I just showed you guys, the Beaver, you can create store procedures there, and still it works with RDS. Right. So you are working with RDS here and Aurora, all of this, guys. This guy has MariaDB. It doesn't have Aurora, but with these guys, you can create store procedures and things like that, and still you can use them and connect them to AWS. Here we have Redshift. You see Redshift here? So this is an amazing guy. So guys, if you can give it a try, when you have some time, try to use this guy. Do some research and try to use this guy. This guy is super, super powerful. I like it. Even with the databases in Azure, you can still use it. Okay. Another cloud provider. Okay. So Amazon Aurora, it replicates by default. It replicates the data, 2 copies in every availability zones. So six copies in total, right? It replicates that in 3 availability zones, 6 copies just when you start. As soon as you create a database, it automatically creates 6 copies of that database and replicates in 3 different 2 copies per AZ. Just right off the bat when you create the instance. Right. Resilient design, you can have when there's a crash, right? Amazon Aurora, what it does, it doesn't need to replay the redo log from the last database checkpoint. Instead, it performs this on every read operation, right? Every time there's a read operation, there's a backup operation. That reduces the restart time after a database crash to less than 60 seconds in most cases. So with Amazon Aurora, the buffer cache or cache is moved out of the database process, which makes it available immediately at restart. This reduces the need for you to throttle access until the cache is repopulated to avoid brownouts. So it's amazing, guys. It's super good, right? So every time there's an operation, Aurora will back that up. So you don't have to back it up every day. There's a backup operation every time there is a read operation.
It's kind of like an Oracle database.
So Amazon Aurora features high performance and scalability, high availability and durability, multiple levels of security, compatible with MySQL and Postgres. Right? Okay. I said here that it reproduces 6 copies, right?
Mm-hmm.
Availability zones, and it can use up to 15 read replicas to reduce the possibility of losing your data. So up to 15 read replicas. That's on top of the 6 copies that it makes. Okay. So the right tool for you for the job, right? What are my requirements? Enterprise class relational database, right? Like we saw in this module, the cloud continues to drive down the cost of storage and compute. All the time, AWS is reducing the price, right? So when you have a database, you have requirements, right? So to be able to support these requirements, right, you need both relational and non-relational databases that have a purpose to handle the specific needs of your application. So AWS offers a broad range of databases that are built for your specific application use cases. Okay, so if you need enterprise class relational database, then you have Amazon RDS. If you need fast and flexible NoSQL database service for any scale, Amazon Dynamodb. Now, if you need operating system access or application features that are not supported by AWS database services, databases on Amazon EC2. And if you have specific case-driven requirements, machine learning, data warehouse graphs, then you have AWS purpose-built database services. There's another database which is a graphic database, and the name is Netune. So this, guys, is a graphic database. Netune is
Graph SQL,
sorry,
kind of like Graph SQL.
like Graph SQL.
Yeah.
I don't know that one.
Okay.
I never used that one. Oh, Graph SQL. Oh, yes, the one that uses JSON.
Yes.
Yes. I tried to learn this guy once because I was using this with DynamoDB. I didn't learn it that much, but it's the College Board, what I worked at, they use GraphQL to query a DynamoDB table. Neptune is different. It's a graphic database. This GraphQL is just, it's an open source data query, a manipulation language for APIs. Special is very good to work with DynamoDB. DynamoDB is a JSON document, JSON database, and this is JSON too. So it's very helpful with databases. So Amazon Neptune is a fast, scalable graph database service. Neptune efficiently stores and navigates highly connected data. Its query processing engine is optimized for leading graph query languages, Apache, Tinker, high performance. Open Graph APIs. Guys, this is not in the scope of this class, but let me tell you something. It may show in the exam. I don't know, for some reason, AWS doesn't include this in the course, but it shows in the exam. So I don't know, guys, if you remember that I gave you a list of services that were not going to be covered in the course.
Yeah.
And then I said, guys, take a look at this, at least know what they're for, so you're not surprised in the exam. Okay, so Neptune, if I don't remember wrong, that should be in the list that I gave you. Okay. Okay, so we have a case study here. So a data protection and management company that provides services to enterprises, they must provide database services for over 55 petabytes of data. They have two types of data that require a database solution. First, they need a relational database store for configuration data. Second, they need a store for unstructured metadata to support a deduplication service. After the data is deduplicated, it is stored in Amazon S3 for quick retrieval, and eventually moved to Amazon Glacier for long-term storage. The following diagram illustrates their architecture. Go to the data center. We have this guy here. Sorry. Okay. So what do you think we should work there? Okay, what do we have here? We have the corporate data center, right? And then we have the cloud here. What do you think that we may need here, for example? Sorry. What do you think it might be, for example, metadata database?
DynamoDB?
Correct. It says here unstructured.
Yeah.
DynamoDB. DynamoDB is the database where you put the metadata. For example, you have a picture, right, of a person, let's say a profile of a person, right? You put the database in the S3 bucket, you put the picture of the person, but the profile information, you save it in a DynamoDB table. You don't save pictures in DynamoDB. You don't save that. You save it in an S3 bucket, right? And then the information of the person, you put it here, right? Now you have the corporate center, and then you're moving to the cloud, and then you need a configuration database, right? So here, you may use the data conversion tool, right, to move to the cloud, right? In case you have, maybe you have a specific schema, right? And you need some configuration before you go to the cloud, right? So the second one, it says a solution, a commercial shipping company that uses on an on-premises legacy data management system, they must migrate to a serviceless ecosystem while they continue to use their existing database system, which is Oracle, based on Oracle. They're also in the process of decomposing their highly structured relational database into semi-structured database. The following diagram illustrates their architecture. So what do you think?
Rds.
Okay, they have a structured one into a semi-structured database. Which one is unstructured or semi-structured? And it works with Lambda.
I know.
DynamoDB. Yeah, DynamoDB. DynamoDB. That's the one that works with the, when you have a serviceless architecture, the duet, the two guys that work in harmony among other services is Lambda and DynamoDB. They work together as a team. One to serve the metadata, and the other one to fetch the metadata from the database. Okay, they constantly working as a team, right? Now, of course, it says here structure, that's Oracle, into a semi-structure, that's Dynamodb. Okay? An online payment processing company that processes over 1 million transactions per day, they must provide services to e-commerce customers who offer flash sales, sales that offer greatly reduced prices for a limited time, where demand can increase by 30 times in short time period. They use IAM and AWS KMS to authenticate transactions with financial institution. They need high throughput to these peak loads, for these peak loads. The following diagram illustrates their architecture. So what do you think?
Aurora?
Makes absolutely sense. It makes absolute sense. Good. Because that's a lot of transactions per day. Super strong database. And it has read replicas. Remember that it has up to 15 read replicas, right? And 6 copies across 3 availability zones, super availability zone. Okay. Good. Any questions, guys? Now one, many, yeah? No questions? This is a good class. Nobody has a question. Okay. So module summary. In summary, in this module, you will learn how to explain Amazon relational databases, Amazon RDS, identify the functionality of Amazon RDS, explain Amazon DynamoDB, identify the functionality of Amazon DynamoDB, explain Amazon Redshift, explains Aurora, and perform tasks in an RDS database, such as launching, configuring, and interacting. Okay. Long class. Question for you guys. Which of the following is a fully managed NoSQL database service?
DynamoDB.
AWDB.
DynamoDB. Super easy, yeah? Okay, guys. We finished this part. I'm going to do something. Who wants to take control of my screen? Who wants to take control of my screen? Or who wants to share their screen? 2 options.